this problem we're asked to find V0 using mesh analysis. If we look at our circuit, we don't have any current sources, so we won't have any constraint equations. There are 3 meshes in this circuit, so let's assign mesh currents. So we have 3 mesh currents. So we're going to need 3 equations. And since there are no current sources, we won't need any constraint equations. So let's start by applying KVL to the 3 meshes. So with mesh number 1, okay, we'll start here. We'll have 2K I1 plus 3K I1. Then we'll have 4K times I1 minus I2 plus 3K times I1 minus I3. We'll treat that dependent source for now like an independent source. We'll write 0.5 Vx minus 10 equal to 0. Okay, so now there's our first equation, and we can take that equation and say we're going to have to do something with Vx. So if we look at where Vx is in the circuit, and if we want to express it in terms of the mesh currents, we're going to need the current in that direction. And the current in that direction is I2 minus I3. Okay, so V0 is 6K times I2 minus I3. So let's go ahead and make that substitution and eliminate Vx from the problem. So if we look and collect some terms, we'll have 5K I1 plus 4K times I1 minus I2 plus 3K times I1 minus I3. And then we'll have 0.5 Vx. We'll have 0.5 times 6K times I2 minus I3 is equal to 10. So this term is really 3K times I2 minus I3. So if we collect up terms here, we'll have 12K I1 minus 1K times I2 minus 6K times I3 equal to 10. Okay. So there's our first equation. So now we need to go through and do the 2 other equations. So we'll take our circuit and apply KVL to the other 2 meshes. So here's our circuit with our currents. So now let's do mesh 2. So if we start, we'll have 4K I2 minus 12. We'll have 6K times I2 minus I3. That's the voltage here. Then we'll have a drop here, which is 4K times I2 minus I1 equal to 0. And then if we collect up terms, we'll have minus 4K I1 plus 14K I2 minus 6K I3 equal to 12. Okay, there's the second equation. Now for mesh 3, we start off, we have 6K I3. We come around, we have minus 0.5 Vx plus 3K times I3 minus I1 plus 6K times I3 minus I2 equal to 0. So now let's work on that equation some. So we have 6K I3 minus 0.5 times 6K times I2 minus I3 plus 3K times I3 minus I1 plus 6K times I3 minus I2 equal to 0. And then this reduces down to minus 3K I1 minus 9K I2 plus 18K I3 equal to 0. So here's our third equation. So now we're ready to enter the data into MATLAB. So here's a matrix that we would enter into MATLAB. So using MATLAB, here's our answers. I1 is 1.5644 milliamps. I2 is 1.802 milliamps. I3 is 1.1617. And if we look back at our circuit, we can see that V0 is 6K I3. So then V0, 6K I3, 6K times 1.1617 milli to give 6.97 volts.